Hey guys, how are you? Today we are going to do CCD PCA analysis. This analysis is really good for calculating flooding areas, especially in desert area. Normally in desert areas, SAR do not work well. It shows most of the area as water body. So this analysis is pretty good for that data assessment. So let's continue for our basics. And dataset we are going to use is Sentinel-1 SLC product. This product got both uh, phase information and amplitude information. This phase information is further can be used for INSAR, CCD, and both of these information combined can be used for polymetric, SAR polymetric interferometry. Software we are going to use is ArcGIS Pro, SNAP. Each one of them can also work, but the advantage of ArcGIS Pro is further vectorization and mapping. So first in this analysis we are going to use SNAP for these two analyses. We will analyze and visualize, and further we will take the product in ArcGIS Pro and do the vectorization, and we will also calculate its area, flooding area. Sorry. So what is CCD PCA analysis? So CCD stand for Coherence Change Detection and PC stand for Principal Component Analysis. Uh, CCD means we will take just correlation between two SAR images by comparing their amplitude and phase. And for PCA, PCA converts the dimensionality in a much reducer form. For example, if we take 3, 4, 5, 7 images and input it into a PCA, it will use its mathematics of eigenvectors and magnitudes, and then it will give us different components. And these components are further divided into information. The first component will have much higher information, the next component lower, 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 and so on. So first three components mainly got 90% of the information as shown in here in the figure. So that's the main component that we are going to analyze, and one of these component is going to be our flooding area. The next component is going to mainly show us and the noise. We will ignore that one. So primary flooding area is going to be Al Ain from UAE. Recently this year on 12 February 2024 there was a lot of waterfall precipitation over there, especially in UAE, Dubai, Abu Dhabi, Sharjah, and such areas such as Al Ain. And the other primary purpose of this event is we will take SAR imagery right on the day of the precipitation, so we will get pretty good results of it. So here you can see the pre-flood imagery is good, and post-flood imagery from Sentinel-2 is cloudy. We cannot see over here, and uh, that's why we are going to use SAR imagery from Sentinel-1. It's really good for such weathers. Now, first of all, we are going to download the images, and so for that, mark the area. That's all in dates. I'm going to go from January to the last of February, and from filter let's just keep SLC product and search. Okay, so these are our results. And one thing I forgot to mention was this. So The primary purpose of this analysis is going to be we are going to create correlation between pre-images, pre-flooding, pre-disaster images, and coherence between pre and post-disaster images. And then we are going to compare them using PCA. So for example, disaster happened over in these red circles. So we are going to take correlation between last one of pre-flooding image and post-flood images and these pre-images, and we are just going to compare them. So let's carry on here. So here we got flooding over on February 12th. So we will take just this one January 21 imagery and compare it with all of them for to get correlation. For that, I will suggest just use this website. It's a really great website. They have provided us uh, a really good analysis, and that takes a lot of time. And like I used to do it before, like 2-3 years before, and I had to do a lot of work for that one. So just take this, and we'll take its baseline. Now just okay, all of them have been submitted over here, and we are just going to reduce this one and submit. Okay, it will take around 2 to 3 hours, so maybe 1 hour, 2 hour, depending on your area. So after that, we are just going to go over here, submitted product, and we will load like after this is that have been run. So just carry them into the carts, and I have already did it before, so I'm just going to download them from here, copy URLs, and from here just check all and carry on. So I have already did all of that before, so I'm just going to ignore it, and we will go to SNAP ESA. Okay, from here we'll let's just go over the data. So these are the files, we have extracted them, and from the extracted files we are going to use this one file only. It represents the coherence. We also got the SAR and other stuff, but it's not important right now. So I have taken all of these coherence files into one folder, and one by one we are going to import them. Okay, so once all of them have been imported, we are going to stack them into one imagery. It's really good to stack them all because similar pixels will get along. Otherwise, sometime there are some errors. Okay, so it's all good. So these two images are pre-flooding images, pre-disaster images. These two are the post-disaster images. So okay, run. Okay, it's complete. Now let's visualize the area. So that's going to be our main area that we are going to study. So, yes, just keep this much is good, I think, and we'll subset this area. Okay, and save. Okay, so as I said, first two bands represent pre-disaster and the next two bands represent post-disaster. For example, if we cover over here, there is a low correlation in the flooding areas, and in the pre-flooding areas, pre-disaster images, we got good correlation. So we are going to take its mean. It's just simple mathematics. Now we are going to take its difference just to be confirm, and it will also make our analysis easier. And by taking the difference, the higher value will show us flooding areas and lower value will show us non-flooding areas. Like, I mean, if it's above 0, that's going to be flooding area. So just to keep out the noise, you can also put the threshold or maybe 0.5, 0.1. It will give you the results, or maybe 0.2, depending on your analysis and your coverage and also your validations. So now we are going to do the PC analysis. That's a good thing about PC analysis, that it also take out the noise and give us the main flooding areas. Okay. That's our main components, 3 components, and just by looking at them, the third component is composed of noise. Component 2 represents the flooding areas very easily. Here you can see in the dark areas are flooding areas, rest of that is non-flooding area, and this one contains all of the information: noise, non-noise areas, flooding areas. Like here, if you say post-flood, pre-flood, it's kind of in between component 1. For example, here, like I said, it got all of the information. So you can also use this one to visualize this, or maybe use it for further analysis. So from here on, you can take just unsupervised classification. Maybe 10 band is enough, and rest of first two components is really good for it. And run. Okay, so now we are going to just make an RGB of first two components. Here the red areas will show us flooding areas. So if we compare them with classification, mainly these two components are representing the flood areas. Here the number 5, if I convert it to red, black, and this one, red one, number 7. Yeah. Now we are going to take this classified imagery into ArcGIS and just vectorize it, calculate the area, and that's going to be the end of our analysis. Okay, it's complete. Just open the attribute table and we are going to select fifth ID, grid code 5 and 7, and separate them. So that's our flooding areas. And just to keep everything good, we are going to merge these two attributes into one. Okay, clear, save, and now calculate its area. I don't know what's wrong with it. Normally it works well. Okay, so I will carry on. Okay, so there's the flooding area, and here you can see also that's the drainage network of this city, and you can see over here signature marks for this network all the way over here, and you can see visualize the same thing. It's going around the city. Due to the heavy precipitation, there was a lot of flooding and streams going at a really high speed. So that cover our analysis, and this analysis is really good for the desert region. It's a little bit lower at the resolution, but it will work for this area because other methods do not work. The simple threshold method using SAR imagery do not work over desert area, and the optical imagery are mostly cloudy. So if it works, otherwise it's cloudy. So SAR is best for flooding and due to heavy precipitation. So that's all.